Yeah. So today we are going to talk about the chemical properties of benzene. First chemical reaction, that is electrophilic substitution. Okay, so give the headline. First chemical property, what we are doing, electrophilic substitution. Okay. So in electrophilic substitution, understand. Arnav, how are you? Arnav, can you hear me?
Good evening, sir.
Good evening, Arnav. You missed few classes, I guess, in between. Did you watch
Yes,
the
sir.
recording? Did you go through the recording?
No, sir. Like I still have my exams going.
Okay, okay. When your exams getting over?
It'll get over by 27.
27th, all right, okay. So I want you to just take a note of this. So we are started with chemical properties of benzene, and the first thing we are doing is electrophilic substitution.
Okay, sir.
Yeah, hi Tanvi, how are you? Quickly take a note of it. Electrophilic substitution we are starting. Okay. So guys, first of all, understand this is your benzene. Can everyone see this? So in the benzene, what will happen? You will add the electrophile. What you will do? You will add the electrophile, okay? And you will get this. Now I have a question to ask to you all. You can see one electrophile is added. So electrophilic substitution means one electrophile will be added, another electrophile will be removed. Hi Ditya, how are you?
Hi, sir, I'm good.
Okay. So yeah, so my question to you all is that electrophile is added on the benzene ring. So it is a electrophilic substitution. One electrophile is added, another is removed. My question is, what is removed from here? Guys, tell me, what is it removed? What we did we remove? Avantika, tell me the answer. Hello.
So we removed the bond.
We removed, no, double bond is still there. See, the alternate double bonds are still there. It's still intact. We removed hydrogen. The what was removed here was H plus. One electrophile. Electrophile means electron deficient species, electron loving species. Hydrogen was removed and the new nucleophile came up. So write down this as it is a three-step reaction. What is it, guys? Write it down. This reaction, electrophilic substitution, is a three-step reaction. Now, what are the three steps? What are the three steps, dear students? So all of you write it down. First step it is generation of electrophile. First step is generation of electrophile. First you form this electrophile. Electrophile is generated. Second step you will write, that is attack of electrophile. Second is attack of electrophile. And the third one, final, you will get the product, removal of old nucleophile, electrophile, sorry. So removal of, guys, removal of old electrophile, okay? Guys, write down this three-step reaction. So we will study such example, Friedel-Crafts alkylation. So let's see one example we will study. So all of you give the headline, we will do. So we will discuss Friedel-Crafts alkylation, guys, FC alkylation. Now, all of you give this headline, Friedel-Crafts alkylation. Alkylation means you add, online students, please tell me if the board is visible and clear to you all.
Yes, sir.
Okay,
Yes, sir, it's clear.
did anyone missed anything above? Everyone has written, right? So guys, Friedel-Crafts alkylation means you are adding a alkyl halide. Okay, so what we will do, we'll take the benzene ring. Okay, all of you see this, and we will add CH3 Cl Rx alkyl halide. Okay, that's alkylation. In the presence of anhydrous, in the presence of anhydrous AlCl3, or you can also use FeCl3. You can use either. Now question is, what does it represents? AlCl3 or FeCl3? Technically AlCl3 or FeCl3, they are Lewis acids. What they are, guys? They are Lewis acids. Lewis acid means they are hungry for electrons. Because if you see the structure of AlCl3 or FeCl3, their octet is not complete. Right, Avantika, Tanvi, Aditya, everyone can see this? Their octet is not complete, right? Now, so Lewis acid means what will happen? Now understand, this AlCl3 will pull this one electron up, will pull this chlorine, right? This AlCl3 will pull one chlorine to form AlCl4. So as a result, what will happen? Chlorine will take the electron and go away, right? Correct? Getting it? So what will happen when chlorine takes up the electron? Who loses it? The carbon. So this carbon will have a positive charge. See, the generation of electrophile is done. Okay? The generation of, so electrophile is generated already, right? Now what will happen? This electrophile, you know this double bonds, guys, please see here. The benzene has a alternate double bonds, right? These pi electrons are electron rich species. You know they are nucleophiles. What they are? Nucleophile. Electrophile, nucleophile love each other because nucleophile has to donate electron, electrophile has to accept the electron, right? So understand this will attack here. It's not compulsory you attack here, you can attack anywhere. Okay. So as a result, what will happen now? Tell me, you will get what? You will get something called as toluene. Methyl benzene will be formed. So my dear students, this compound is called toluene. So it is a conversion method which gives you toluene. Everyone take a note of it. Guys, got understood the reaction or not? Tell me. Tanuj, how are you?
Hello, sir. I'm good, sir.
Tanuj, quickly give the headline chemical properties, chemical reactions of benzene and copy this quick, okay? This is the first reaction we did under electrophilic substitution, okay?
Okay, sir.
Friedel-Crafts alkylation. Okay. So guys, let's do one question now. So let's do a question. Question says convert phenol to toluene. How will you do this, guys? Convert phenol to toluene. Everyone, try this question. I want you all to try. Okay. Ritvik, you have any idea how will you do this? Say,
Oh, no, sir.
don't say no. See here. You already learned how to convert benzene to toluene. So your mind should think about how to convert phenol to benzene. And in the previous class, we discussed one method where we were converting phenol to benzene. What was that? Using zinc dust. Yes, we learned that, no? I told you before, I'm telling you again, I have told it million times, and I've been telling this from last 10 years that conversions, preparations, Chemical properties are not just that, it is conversions. It's very important. You need to know that. This is how the questions will come in the exam, okay? So first you will take phenol. Avantika, you are clear?
Yes, sir.
So first you will take the phenol. After that, what are you going to do? So in phenol, you will add the zinc. You will add the zinc dust. So what will happen now? Wait, let me write the phenol more properly. So you can write it as like this. So what's going to happen? Zinc will acquire this oxygen, right? Zinc will take out this oxygen. So what will be left behind now? So what you got is benzene. See? And now you know what we have to do. So carry out Friedel-Crafts alkylation, FC alkylation, we just learned, and what we will get is toluene. Done. Guys, see this? Understood everyone? Is everyone clear? Advitya, Tanvi, Shreya?
Yes, sir.
Okay,
So can you
perfect.
explain? So can you explain again?
Uh, which part do you want me to explain? Tell again.
So the ZNO part, where did that go?
Yeah, zinc will remove the oxygen, right? So ZNO is a byproduct minus ZNO. That's it. I hope it's
Okay.
clear.
Yes, sir.
Yep. All of you take a note. We'll discuss the next question now. Okay, let's write one more question. Guys, one more question. This was the first. I'll give you second. One more question. Convert benzoic acid to ethyl benzene. Guys, try this one now. Please convert benzoic acid to ethyl benzene. See, toluene was methyl benzene. Now you have to get ethyl benzene. Everyone give a try. Anyone has a clue what we will do? Anyone can tell me what we are going to do? Avantika, can you tell me what will be done?
So would we do decarboxylation,
Yes, you are absolutely right.
and then we, instead of CH3Cl, we do C2H5Cl.
Yes, very good. So first of all, very good. Yes, Pranav, you are also saying something. See, this is benzoic acid, right, Shreya? Can you see benzoic acid?
Yes, sir.
Now, in the benzoic acid, you react it with first with NaOH. Acid-base reaction will happen. It means what will happen? There will be minus and plus. This H plus will be removed. Here plus minus. Okay? So OH minus will go with H plus, right? So it will form H2O. Acid-base reaction forms salt and water. What will be the salt? In place of hydrogen, you will have sodium. So you get sodium benzoate. Is it clear? Once you have the sodium benzoate, you can do decarboxylation. How do you do decarboxylation, Avantika? You add, what are the things you will add here?
NaOH, and then
NaOH.
that soda lime.
Yes. Soda lime is NaOH plus quick lime, right? CaO, right? I hope it is clear. Guys, got it, no? Kindly confirm. Heating is also I missed. You need to take a heating into consideration. So it will remove the Na2CO3. CO2 is removed in the form of carbonate, right? Na2CO3 will be removed, my dear students. Okay, and what will be left? Let me show you. Let me demonstrate you how Na2CO3 is removed. CO3 and Na2. This whole thing gets removed, my dear students. Please see this. Na2CO3. Can everyone see this? So what is left behind now? Whatever is left behind, that is your benzene. Now in benzene, what you'll do? Friedel-Crafts alkylation. So you will add what? C2H5 in the presence of what? Lewis acid, right? AlCl3 anhydrous, correct? So what is gonna happen? This bond will break, correct? Cl will go there. So there will be an electrophile. This electrophile will attack there. As a result, what do we get? We will get this C2H5. That is your ethyl benzene. Aditya, did you understand this? Kindly confirm.
Yes, sir.
Okay, Tanuj, you got the reaction? Hello, Tanuj, can you confirm? Arnav, are you clear?
Yes, sir.
Yes, sir.
Okay, now, so let's learn the next reaction, guys. Now write down Friedel-Crafts acylation. So after learning this Friedel-Crafts alkylation, give a new headline, my dear students. We will discuss Friedel-Crafts acylation. Friedel-Crafts, Friedel-Crafts, okay, acylation. Guys, write it down. Friedel-Crafts acylation means in place of alkyl halide, in place of alkyl, you will add acyl. Let me tell you what is that. Friedel-Crafts acylation means you will take the benzene ring, you will add acyl halide. It means I will take an example of CH3COCl. This is called acyl group. We call them acid halide or acyl, okay? Acid halide. I hope it is clear. And in the presence of same to same thing, guys, we will carry out this reaction in the presence of anhydrous, same thing, AlCl3, which is a Lewis acid, right? Guys, please check it out. Now tell me what is gonna happen here. The chlorine will take the electron and it will leave. So plus charge will come here. So what is our electrophile here? Who is our electrophile? We have electrophile is this. Guys, please look at your electrophile. Can you all see this? This is your electrophile. This electrophile will attack here, right? So what do we get? What do we get now? We will get something like this. C double bond O CH3. This compound is called acetophenone. Acetophenone. Write it down. Acetophenone. Okay. This group is called acid halide. Okay. Got it? No? But because we have specified a chlorine here, so what will be the name of this compound? Acetyl chloride. If they ask you what is the name of this, it's called acetyl chloride. Write it down. All of you take a note of this. In general, we say acid halide. Friedel-Crafts acylation means addition of acid halide. Acylation. Friedel-Crafts alkylation means alkyl halide. Yes. Is everyone clear about this? Hello?
Yes, sir.
See, the same acetophenone can also be written like this. This acetophenone you will find in textbook written like this: PH C double bond O CH3, or they can write it like this. So don't get confused. They write it like this: C6H5 C double bond O CH3. They all are acetophenone. See that? Okay? We call them acetophenone. Understood, everyone? Guys, remember, benzene ring is a electron rich species. Electrophile is a electron poor species. That is why the reaction is very good. Okay. Benzene ring is a nucleophile. Electrophile is a electron. So that is why electrophile, nucleophile love each other. They have a very high tendency to react with each other because one has to donate electron, one has to accept electron. So both requirements are fulfilled. Is it clear? All right, no? So take a note of it. So one more reaction we will see. So it's not about only acid halide. You can also add acid anhydride. Let me explain you that. So I'll take you one example of acid anhydride because that also is considered as Friedel-Crafts acylation. So reaction number one, reaction number two. Okay? So let's take the example of that: CH3, C double bond O, C double bond O, CH3. Guys, please see this. This is called acid anhydride. Acid anhydride. Check this out. Is everyone clear? Acid anhydride. Now, see this. Acid anhydride, guys. What is gonna happen here? You will break this, either break this bond or this bond, up to you. You break any one bond, okay? Guys, please see here carefully. You either break this bond or you can break this bond. At one side, one bond will break. Is it clear? So let's assume the oxygen took the electron. So what is happening? This is our electrophile O minus. Can you all see that? We are breaking the bond here. Tanvi, Shreya, understood? No?
Yes, sir.
So what is our electrophile? Same. Our electrophile is same. See, this is your electrophile. This electrophile now will attack here. So what is we get? Again, we will get the same substance, acetophenone. We again got the same substance, acetophenone. Plus, there will be a byproduct. Guys, here The hydrogen which is removed from here, that H plus will go with this O minus. So the byproduct will be a acetic acid CH3 C double bond O OH. O minus will get the H plus. So acetophenone plus acetic acid. This is your byproduct. Okay. Avantika, did you understood this reaction?
Yes, sir.
So write it down one point. Okay, all of you first copy this and revise for a minute, then I'll continue. Guys, so whatever the reactions we have done till now, please revise it. Hmm.
So the H plus combines with the O, right? Like
Yeah, what are you saying?
the H plus combines with the after O, whatever part is there, right?
Ha. O minus will get the H plus, simple. Okay. ठीक है?
Yes, sir.
Alright, guys, now. So let's see the next one. Did everyone revise? Take 2 minutes of time, guys. 2 minutes, revise all the reactions what we've done. Revise it now, quick. Alright, is everyone done? Online, please confirm. Did you all finish?
Yes, sir.
ठीक. So now give the new headline or write one important point. Guys, I want you to write an important point. So write an important point if so guys write it down. If excess if excess of reagent is added, right, which is electrophile, right? If excess of electrophilic if excess of electrophilic reagent is added. So if you are adding a electrophile reagent in the excess, is it clear? Further substitution may take place. Further substitution will take place. So let's see the example here. You need to remember this example also. So we'll take a benzene ring and we add 6Cl2. Can you all see this? In the presence of any gases, guys, how do we add? Same Lewis. Yes, remember, in the presence of anhydrous AlCl3, but the condition should be dark and cold. There should not be a sunlight. I hope it is clear. So now let's see what you will happen. So at every place you will see chlorine is added. Guys, please see this. At every place we will see the chlorine is added. All of you, please see this. You will look at the chlorine. Now tell me, at every position hydrogen is added, removed, right? So how many hydrogens are removed? At every position when chlorine is substituted, how many hydrogens are removed? There was 12 chlorine, 6 was there, right? Yeah, so those 6 hydrogen will bond with the remaining 6 chlorine to form 6 HCl. Okay, write it down. So what is the name of this compound? We call it as, what's the name of this compound? It's called as hexachlorobenzene. Hexachlorobenzene, 6 chlorines are there, right?
So
Yeah, ask your question again.
how is this an example of excess electrophilic reagent being added?
Because chlorine is added in excess. I think you are clear now. You are not adding Cl2 just. You are not adding Cl2. You added 6Cl2. This is excess.
So what
Okay.
if like we add some excess acid halide or something like that, or alkyl? Isn't that like excess?
Yeah, basically what you're telling is you will add excess of alkyl halide, right?
Yes, sir.
See, in that case, there won't be a substitution. Okay, only one place it will acquire. Okay, because for that, understand there are more conditions which are needed. So this happens only at certain cases. Like this one, you need to know. Okay, there are a bit more. I'll tell you that. Okay, Avantika, you got it, no?
So only this like when you add chlorine is one of the examples, right?
Yeah, you can add also bromine also. You can add bromine also here. Okay, halogen. Okay.
So also what does dark cold mean?
Cold means at the cold condition like 0 degrees Celsius. Dark means there should be no sun, no sunlight. Because if sunlight is there, there will be some other mechanism. Okay? Antika, you got it, no?
Yes, sir.
Okay. So guys, now write down a new headline, electrophilic substitution. Oh, my bad. Electrophilic. Oh, no, that I'll tell you later. Guys, once again, there are more actually. So as of now, we have learned, alkyl halide, Friedel-Crafts alkylation, Friedel-Crafts acylation. Now give nitration. So the third reaction you will learn is nitration. Guys, give the headline. For the third reaction, what is that? Nitration. All of you write a note. Now what will happen? We will use the reagent. In reagent, what do we use? The reagent you have to remember, it's important. That is concentrated HNO3 plus H2, my bad, plus concentrated H2SO4. So what will be the electrophile from this reagent? The electrophile you will generate from this reagent will be NO2 plus. This is your electrophile will come out. Now let's see the reaction. So reaction will be when you add concentrated HNO3 and concentrated H2SO4. This will give up NO2. So from this combination, NO2 will come up and that NO2 will attack at the benzene. So what do we get? So understand what do we get here? So we get a nitrobenzene, guys. What we get? So guys, I'm reminding you again, you are learning conversions. What you are learning is conversions. I hope it's clear. Okay, remember this. And heating is also accompanied. So H2O is your byproduct. Now write down the next reaction, fourth one, that is sulfonation. So guys, you will do sulfonation. Write down the reagent you are using. Reagent you are using for sulfonation is fuming sulfuric acid. Fuming sulfuric acid. Now, what is fuming sulfuric acid, guys? Fuming sulfuric acid means you are adding SO3 plus H2SO4. Guys, got it no? SO3 plus H2SO4, okay?
So can you explain nitration again, like the plus sign you made there?
Yeah, that is your electrophile, right? NO2. So this electrophile will attack here, right? You got it no?
Yeah.
This is
So,
a nu
so
this is a
concentrate.
nucleophile, this is electrophile, perfect match. Got it no?
So concentrated HNO3 and H2SO4 is a medium for it, right?
Yes, that is a reagent which gives out NO2, NO2 plus has a electrophile. Understood?
Yes.
So guys, fuming sulfuric acid means, tell me what will happen when you add these two, tell me, what do we get? H2, S2, what are you getting when you add these two? H2, S2O7, right? This is called as oleum. Remember, oleum is a substance we use in manufacturing of sulfuric acid. This is called oleum. What do we call? Oleum. Now, what is the electrophile will be here? So in this reaction, the electrophile is HSO3 plus. Guys, write down this. Okay, all of you write down the reaction. Okay, you can either write it as HSO3 or SO3H. You can also write it as SO3H. Okay, so let's do the reaction now. So we will react, SO3 plus H2SO4, fuming sulfuric acid, that will give out this. So we will get benzene sulfonic acid. So our answer will be, this product is called, Arnav, you understood?
Yes, sir.
Benzene sulfonic acid. Guys, write down this. Okay. And yeah, of course, I forgot the H2O. So remember again, they all are conversions what we are doing. Okay.
So how does the SO3H come from, like the oleum, right? Like from there, how does it come?
Yeah, so there is a detailed mechanism about how NO2 plus is coming out and how, HSO3 is coming out. So that you don't have to know, but still I'll tell you one, okay? So let's know the mechanism of this, okay? See, that is not required, but still I'll just tell you one mechanism. Mechanism of nitration. Now, Antika, tell me what is the reagent we were using in the nitration? Can you tell it once?
Concentrated H2SO4 and concentrated
Yes,
SNO3.
so can we write it like this? Plus HNO3. Tell me, can we write like this? This is your sulfuric acid. Can you see that? H2SO4 and HNO3. Can you see that? Now say this oxygen has a lone pair. Guys, do you see this? There is a lone pair on the oxygen. Now understand this oxygen is more electronegative. This H plus will be compensated by here. Guys, getting it? What is happening? Tanvi, you got it? Advitya,
Yes, sir.
this lone pair will be donated to H plus. Oxygen is more electronegative, will take up the electron. So this will be minus, correct? So as a result, what do you get? As a result, you will get something like this. H, there will be a positive charge, hydrogen. Wait, just a second. Let me remove this positive charge. I'll put NO2. Where should I indicate the positive charge? I'll indicate the positive charge here. Chotu sa. Plus HSO4 minus. Huh. Guys, so see what happened now. This is taken up the electron, so it is SO4 minus, SO4 minus, HSO4 minus. And what happened here? In this oxygen, what came up? This hydrogen. So oxygen has donated the lone pair, that is why there is a plus charge. I hope it's clear. Guys, kindly confirm. Did you all get it? Please confirm it once. And yeah, one more thing. If this is not NO3, because NO is already there, right? This must be NO2. Then only it's HNO3, right? A small error is there. Fix it, guys. See, it's HNO3, so it should be NO2, right? Now it is fine. Avantika, you understood the first step?
Yes, sir.
Now take down this structure here. Bring this here. So H. Now, do you know oxygen is electronegative or electropositive, guys? What is the nature of oxygen? Tell me. Tell me what is the nature of oxygen? Is it electronegative or electropositive? It's electronegative. A electronegative atom is highly unstable when it has a positive charge. A electronegative atom should have a negative charge. But what is the charge here? So it will somehow cancel that charge. So what it will do? It will take up the electron from the NO2. So it will take up this electron. Is it clear? The NO2 will lose. So as a result, what you'll get? So this H2O is removed. If you see, oxygen will take up the electron and it will form a very stable compound, that is H2O plus, what did you got? NO2 plus. That's how. So that is how your electrophile is generated. Electrophile generated. And then once it is generated, it attacks and removes the hydrogen. Avantika, you understood now how NO2 came into the picture?
Yes, sir.
Similarly, we actually obtain HSO3 also. But those things you don't need to know, okay? Just need to know what is the reagent and what is the electrophile, okay? So guys, please write it down. Okay. Pranav, you have the NCERT book hydrocarbons, right? Can you show me? Let me check how much is there. We have finished Friedel-Crafts. We also did.
So in NCRT, there's like a mechanism, right? I think of feeding
There
graph.
is a mechanism of only Friedel-Crafts reaction that we discussed, right? Okay, okay. For nitric acid also it's given. So I think you understood, right? We did anyway.
Yes, sir.
So only those mechanism you need to know. Guys, please pay attention. Only those mechanism you need to know what is there in NCRT. So I think both of them we did, right? Generation of electrophile where AlCl3 is a Lewis electron deficient. It will pull the Cl, it will form AlCl4. Then CH3 will attack on the benzene, right? Clear, no? I think we did that. Formation of a ion. Attack of formation of, okay. Remove the proton of this electron. Ortho and para. Okay. Carcinogenicity and toxic. Is it a new book? Yes, yes. Okay. So carcinogenicity I will do, and we'll do ortho meta para directing groups. All right. And before that, I have to tell you about one more reaction, that is actually two more reaction, addition reaction. Guys, all of you write down the addition reaction now. Everyone give the new headline, addition reaction. Guys, write it down, addition reaction, our new topic. Remember, when you do addition reaction, the character will be lost. It will not be a aromatic compound. The benzene aromatic nature will be lost. Remember, keep that in mind, okay? So let's see one reaction here. So one of the reaction is when we take a benzene, and in this benzene we will add 3Cl2. How many? So it is not a substitution, it's a addition. Everything will be added. So it will be added at the cost of double bond. So aromatic character will be lost. So what do you get now? At all the position you will have a chlorine. Avantika, just see this. Tanvi, you have any doubt till here? Advitya, hello? Yes, Advitya, you're saying something. Tanvi?
No doubt.
Okay. Tanvi, you are clear, no?
Yes, sir.
Okay. So you can see that all the double bond are lost. Aromatic nature is gone. And in addition reaction, always it will be like that. Right? Aromatic character will be gone. Okay. And this compound, what do we call it as? Anyone? It's a cyclohexane now. It is a cyclohexane. What do we call it? Tell me. We actually call it as benzene hexachloride. Benzene hexa, benzene hexachloride. Pranav, you got it? Other Pranav?
Yes, sir. Got it.
So we call it as a BHC. BHC, benzene hexachloride. One more thing, this reaction requires sunlight. So you take H nu. Okay. Avantika, you got it now? What happens in without sunlight and with sunlight? Okay. Temperature is also given 500 Kelvin. Okay. Avantika, you understood no? This is in the sunlight.
Yes, sir.
Guys, one more reaction is there. Let's take a note of that also. So another reaction is very simple. We discussed, right? Catalytic hydrogenation. So catalytic hydrogenation is a method where you convert benzene into cycloalkane. Okay. So what you have to do, you will just add, one second. You will add hydrogen in the presence of nickel, palladium, or platinum. Again, it's a addition reaction. All the aromatic character will be gone. And what you will end up with? That's all this. Okay. So it was C6H6. You added 6 hydrogen. So it became C6H14. Okay. This is your cyclohexane. This is your aromatic. Write a note. In the addition reaction, aromatic character is lost. Everyone write a note. Aromatic character is lost.
Sir, can you repeat what you said?
What I am saying is, when you do addition reaction, you can see it's not a benzene anymore. Aromatic nature is gone. Okay? Is it clear?
Yes, sir.
ठीक. Okay. Guys, in 10th grade, you have studied combustion reaction, right? That whenever you burn a hydrocarbon, right, it gives you CO2 and H2O plus heat plus light. One more thing, if the carbon content is high, then it burns with a yellow color sooty flame. And that yellow color indicates the combustion is not complete. It's not complete. That means pollution is coming out, okay? Right, because oxygen is not sufficient. I hope it's clear. So let's leave that part. There's nothing else. Okay. Now I have a question to you all. Ask you all. Guys, please see this question now. My question is, if I have a benzene, I am having a benzene, and let's say this benzene is substituted. Something X is present. Now, if I put X, you might understand it's a halogen. So let's say something Y is present. So guys, assume that this benzene is mono-substituted, means some group is present. This benzene is what is there? Mono-substituted. Now, let's assume that I am adding a electrophile. I am adding a. Now, this electrophile, when it is added, will have a freedom. Now, this electrophile which is added, it can go here also, it can go here also, it can go here also. The question is, how do we know the electrophile will go at which position? So for that, we will study a concept called as ring activating and ring deactivating groups. Is it clear? Ortho and meta directors and para directors. Also remember, this group, whatever is attached here, guys, pay attention. What this is important. Hmm. So guys, please see this. The group which is attached here, please see this, guys. This group which is attached here. Can you all see this? Why? This group which is attached here is called side chain. What do we call it as? Side chain. First of all, understand this. This group which is attached to the ring, mono substitution, right? Side chain. Avantika, you are able to get it? Arnav?
Yes, sir.
So remember one thing, that when there is a side chain, guys, when there is a side chain, the immediate next position, the immediate next positions are called ortho positions. What do we call it as? Next to ortho, these positions, next to ortho position, these positions are called meta positions. And last, this is one called as para. So you remember a trick Om Prakash. ortho meta para, ortho meta para from both the sides. Ortho meta para, ortho meta para. Om Prakash, okay, OMP. I hope it's clear. So now understand, you have to study. First we will study, guys, first we will study ortho and ortho and ortho and para directing groups. Ortho and para directing groups. Give the headline, guys. Remember, these groups are called as ring activators. What do we call them? Ring activators. Now, how do we identify who are ortho and para directing groups? So, if you people have watched my YouTube video on resonance, you might have been knowing. Okay? If you haven't watched it yet, guys, please go to the Chakrayu Science Academy, YouTube channel, and please put the search resonance. You will find the video. Make sure that you go home and watch it. And I want a comment from everyone who watched the video, okay? Everyone should comment over there. Avantika, you got it, no? Arnav,
Sure.
Yes.
Pranav, Ritvik. Yeah, so please do
Yes,
watch
sir.
the video today on resonance. It is going to be very helpful for you. Advitya, do watch it. Tanuj, it's just a 15 minutes video. It's a very small video, okay? Now, Shreya, you also do watch it and make sure you put a comment on the question I asked in the end, okay? Is it clear? So guys, remember this ortho and para directing group, they are called as ring activators, okay? Now the question, what they do basically? So what they do, they directs the incoming, they directs the incoming electrophile at ortho and para position. This directs the incoming electrophile at ortho and para position. It means you will have two answers. One case where it is at ortho, another case where it is at para. Where generally you need to remember the para one will be the major product. The para one will be the major generally, and ortho will be the minor. Okay, generally. Moreover, how do you know who is a ring activator? You will identify. So write it down. If the lone pair is directed, if the lone pair is directed inside the ring, that is ortho and para directing group. That is para directors. Remember, if such groups are present in the ring who are sending electron inside the ring, then they are ortho and para directors. Is it clear? It means they show, it means they show plus M or plus R effect, because plus M is mesomeric, plus R is resonance. So plus M plus R are the same thing. When the lone pair is coming inside the ring, they are orthometa directors. That is called plus M or plus R effect. Okay, this is the theory. Now we'll see some example. Is everyone clear till here? Guys, please confirm. Did you all get it?
So
Hello?
the minor and major is the products, right? Like
Mm-hmm.
minor and major product.
Yes, Avantika, tell again. What do you saying?
The minor and major.
Yeah, there will be two products. One will be
Yeah.
ortho, one will be para. Where Yes. Make sure that you come back by 7:40. All right. Hmm. Yeah. So, Avantika, understand there will be two products. One will be minor and one will be major, where major is going to be formed in more amount, minor will be formed in less amount. Okay.
So like when we had done the chlorine thing and it had two, three products, like that one, same thing, right?
There will be two products. Major means it is formed in large amount. Minor is in the less amount. Okay.
So can you explain the last 2 points?
Last point is lone pair is directed inside the ring. You will understand this when I'll draw the resonance. Okay. So let's take the example of orthoparadactors. So all of you write down the examples. So who are ortho and para directing groups? So write it down. Ortho para directors are, basically the OH groups, OR groups, phenol, then anisole, then who are else? Who else? You can write the alkyl groups, even like methyl, ethyl, all of them. Even the amines are one of those. The amine groups are also, if they are present, you got it, no? Then all the halogens like chlorine, bromine, iodine. Guys, write down these are if they are present in the ring. All of you write a note, guys. If they are present in the ring, they are ring activators. I hope it's clear. Got it, no? There are more. One more you can take. That is this group also are ring activators. So if you see them attached to the benzene ring, that means the electrophilic substitution will take place at ortho and para. Guys, take a note. If you see these groups are attached over the ring, that means they will send the electrophile during electrophilic substitution. At which position? At ortho and para. Online, is everyone clear what I'm saying? So
Yes,
let's,
sir.
yeah, so let's understand how. So let's understand the details. Let's understand the details. So we can take anyone as example, okay? So let's take one as example, guys. So I'll take the amine. My dear students, please see this. I'll draw the benzene ring, and this is your amine. Can you all see this? And if you look at carefully, the amine has a lone pair, right? Now tell me in this structure, wait, I'll just keep it a bit more here. Uh, one sec. I need to draw at least five amines to explain you. Very good. And last one, somewhere down. Okay, all right. So we are ready. Should I explain now? Is everyone ready now? So guys, remember, I have told you if you see any of these groups attached to the ring as a side chain, what they will do? They will direct the incoming electrophile at ortho and para position, where para position isomer will be major, ortho one will be minor. Till here, is everyone clear? I need a confirmation from everyone before I explain this. Ritvik, till here you have understood?
Yes, sir.
Pranav? Pranav, can you confirm?
Yes, sir. Yes.
Avantika, till here it's clear?
Yes, sir.
Arnav,
Yes, sir.
Tanvi,
Yes, sir.
Advitya, Tanuj,
Yes, sir.
Shreya?
Yes, sir.
Good. So now understand, if you see this, the first resonating structure, what you can observe here, what is happening, guys? There is a conjugation. See, I have told you pi sigma lone pair. There is a conjugation pi sigma lone pair, right? So when you see this pattern of pi sigma lone pair, what does it mean? Resonance will happen. So how the resonance will happen? The pi electron will shift here, right? And to adjust this incoming electron, the lone pair will shift here and the pi electron will shift here, right? Yes or no? So you see the lone pair is directed inside the ring. So which effect is this? It is a plus R or plus M effect. When the lone pair is directed inside the ring. Ritvik, you understood this now? You were asking
Yes,
about the
yes,
last
sir.
two lines. Okay. Now tell me, when this is directed here, the nitrogen will have a plus charge. Yes or no? And what will happen? The double bond will come here. Yes or no? Here and here, nothing has happened, so we'll write as it is. Is it clear? Now, where will be the, negative charge? The lone pair extra, it is here, right? Now, do you see the pattern again? Pi sigma lone pair? Yes. So now this lone pair will shift here, right? And this pi electron will shift here. Yes or no? It will take a complete clockwise rotation. So what do we see next now? This will be as it is. This will be as it is. Okay. This is as it is. Now the double bond will come here and the negative charge with a lone pair will shift here. Avantika, you understood this?
Yes, sir.
Now what will happen? This lone pair will go to the next position. This pi electron will go here. So what will happen now? First you write where nothing has happened. So these two are as it is. Now what happened? The lone pair will shift here and the pi electron will be here, double bond, right? Now from where we started, we will go back. You see, that means our resonance is complete. Remember, resonance goes in only one direction. So you'll take one complete rotation from where you started, you'll reach back. That means resonance is over. So finally, what will happen now? The lone pair came back, and what happened also? The double bond came here, here, and here. That's it. Now we will draw resonance hybrid, which is a sum total of all the resonating structure. So in hybrid, you will draw the double bond wherever it was present. See, double bond was present in all entire ring. So that is why we'll draw the circle here. Understood? Plus, if you see the double bond was here also. Correct? Now you will put the partial positive and negative charges wherever they were present. So nitrogen had a positive charge, so we'll put partial positive. And at these positions, at ortho, if you see, at ortho and para positions, there was a partial negative charge. Tell me, Advitya, can you see this? Tanvi, everyone? At
Yes, sir.
ortho and para position, there was a negative charge. It means electron is more. And electrophile is electron hungry species, electron loving species. So it will attack there only where electron is more. So so write it down the conclusion. So due to high electron density at ortho and para positions. Okay, electrophile will attack here. I hope it's clear. You have understood the reason. Very, very important. It's very clear by the resonance. So all of you draw this structure, guys, and write it down. Dear students, please draw this. All of you.
So for halogens, usually the minus I effect dominates, right?
No, actually, in halogens, there is a plus M effect because the halogen has a lone pair, plus there is a minus I. But it was observed that even the minus I is dominated over the plus M. Still, it is showing ortho and para position. So that is an exception. Okay, Avantika?
Yes, sir. So, but like, chlorine needs an electron to complete its octet, so right, it won't give electron. That's why it said that I minus dominates the
I minus
response.
dominates, that is correct actually. But like I said, it is observed, experimentally that being I minus dominant, it's still ortho and para directing. It's exception one. Okay.
Okay, sir.
So guys, write it down.
So what is after there?
That's all. So that's what due to high electron density at ortho positions, electrophile will attack here. Attack there. There means at ortho and para. Okay. I can write it as attack at ortho and para positions. I think it's more better, right? Yeah, it's fine now. Okay.
Yes, sir.
So guys, I am going to tell you now the ring deactivator group. So write it down, the ring deactivator. So this was the ring activator, okay? So I'll let me show you one example also, no? It will be better actually. So let's take one example. Let's suppose there is a identify which compound is this, guys? Phenol. You have just seen phenol is also a ring activator. So in the phenol, let's assume we are carrying out a reaction that is Friedel-Crafts alkylation AlCl3. So we know what will happen. Cl will be removed. CS3 will be the electrophile. Okay. This CS3. Now tell me it will go at ortho and para. So what do we get here now? Don't touch this OH. So one product will be this plus another product will be this. One will be a orthoisomer, one will be a para-isomer. But this will be the major and this will be minor. Guys, understood now? See, this is how we are knowing. This is also a ortho-para directing group, so that is how we wrote the answer, okay? Ritvik, you are able to understand now?
Yes, sir.
Perfect.
So, sir, Cl3 doesn't take part in the Cl doesn't take part in the reaction, right?
No. Understood now? Shreya, did you get it?
Yes, sir.
All right, so perfect, guys. Now give the new headline. See, after we discussed, so write down ring deactivator. Ring and deactivator. So they directs the incoming electrophile at meta position. Which position, guys? So they will not have two answers. They will have only one. At meta position. Okay. So they are also called as meta-directing groups. What do we call them? Meta-directing groups. Now, write down about them more that they will show minus M or minus R effect. Means in this case, you will see the lone pair is directed not towards the ring but away from the ring. In this case, it is directed away from the ring. So, guys, write down these points, okay? Then I'll present you examples. So, we'll see some examples, okay? Ring of ring deactivators, okay? So, guys, examples are there. They are all the groups like aldehyde. Guys, getting it? No? Can you see them? Huh? All these group who have, all the groups who have carbonyl compound, CO, they all are ring deactivators. It's very easy to identify them. Then they are C, C double O R, Cl, then NO2, then CN, benzonitrile, cyanides, nitro groups. Guys, look at them. They all are deactivators. Everyone, please write it down. Hope I have not missed anything. Sulfonic acid I missed. COR I have written, I mentioned COOR. And then last one, SO3H, sulfonic acid. So guys, presenting you all these groups who will direct at meta position. They are ring deactivators. Okay. Now, I think I have explained you a resonance above to show why they go at ortho and para. Similarly, you can take one example and you can draw the resonance to see why they go at meta. Is it clear? Because electrophile care about the electrons. I hope it's clear now. So guys, it is all your homework. Please,
Can you scroll up a bit?
yeah. So guys, listen to me first, then you can write. So today you all will watch the video of resonance and make sure the question I have asked, now you know the answers also. So you put a comment on it. It's wrong, correct, whatever it is. Please make sure you put the answers. And do watch the video. You will know why I have explained the resonance of these compound substance also. Minus M I have shown, okay? So take it down in your notebook and then put the comments. Is it clear? That is your homework. And so hydrocarbon is over. One toxicity thing is there that also you should read on NCRT. However, I'll explain. It's a 5-minute topic. And guys, on the Friday class, we will do mole concept. Okay, mole concept revision 100%. Okay. All right. Bye everyone. Let's meet in the next class.
Thank you, sir.
So have you done thermo?
Avantika, what are you saying?
Have you done thermodynamics?
No, as of now, not yet, but we will do. Okay. Yep.
Thank you, sir.
Yeah. Thank you guys. Bye. Yes.
Thank you, sir.
Yeah. Bye.